Good morning, friends. Today we discuss about the general properties of hydrides of p block elements. What are the general properties of hydrides of p block elements? Today we discuss about these hydrides. When H plus ions are present, then it is hydrogen ion, and when the H minus ions, that is anion, is present, these are known as the hydride H ions, that is the H ions. These are known as the hydride ions. And what are that general properties of hydrides of p block elements? Today we discuss about these. First general properties of the hydrides of p block element is boiling point. Generally, the boiling point from top to bottom in the periodic table of p block element, the generally boiling point is increases due to the atomic or the ionic size is increases, as well as their bonding is due to screening effect, sealing effect, all, as well as their bonding. Due to that, the boiling point of hydride is increases. Generally the boiling point of the trihydrides group first. Trihydrides of group 15 increases, we move down the group. For example, the trihydrides of group 15, ammonia having the NH3, nitrogen attaches with the 3 hydrogen atoms, attaches with the central nitrogen atoms. The abnormally high boiling point of ammonia is due to the association of its molecule through the hydrogen bonding. The ammonia having the strong boiling point of the hydrides, and due to the hydrogen bonding is takes place in the ammonium molecules. And then the second property is basic characters of hydrides. All the trihydrides, generally all the trihydrides have one lone pair of electrons on the central atom. They behave as Lewis bases. On moving down the group, basic characters of the hydrides is decreases. For example, the ammonia molecule, 3 hydrogen atoms attaches with the central nitrogen atoms. On the nitrogen atom, central nitrogen atom, the one lone pair is present, and that NH3 or trihydrides of the molecule, and these are behaves as a Lewis base. Lewis base means it can or it can donate a pair of electron, or lone pair of the electrons. On moving down the groups, basic character of hydrides are decreases continuously. Basic character of the hydrides are, these are the, that is the trihydrides are decreases down the group. This is the second properties of the hydrides of p block elements. Then the third property is the thermal stability. Thermal stability of the trihydrides decreases as we move from NH3 to bismuth trihydrides, that is the ammonia to the bismuth trihydride. This is because of, as you go down a group, the size of the central atom is increases. Therefore, its tendency to form stable covalent bond with comparatively small hydrogen bond decreases. Assume if we consider the group 15th of trihydrides, that is the nitrogen, phosphorus, trihydrides of phosphorus, and then up to trihydrides of arsenic, then bismuth, trihydrides of the bismuth. That is continuously the atomic size of the central atom increases. Central atom, the size of the central atoms are increases. Therefore, its tendency to form the stable covalent bond with comparatively small hydrogen bond decreases. Small hydrogen bonds are decreases. Consequently, the strength of metal and hydrogens, the bond, and hence the thermal stability goes on decreasing as we move from ammonium to trihydrides of the bismuth. Continuously from top to bottom in the periodic table, the atomic size, that is the central atomic size, is increases. Due to that, it forms the stable covalent bond, and comparatively the small hydrogen bond is decreases, and then thus the strength of metal ion hydrides bond, and hence the thermal stability goes on decreases from ammonium to trihydrides of the bismuth. Then the fourth general properties of the hydrides are reducing character. What are the reducing characters of the hydrides? With progressive decrease in the stabilities continuously, that is the decreases in the stabilities. Reducing characters of the trihydrides increases. Reducing characters of the trihydrides are increases as we move down a loop. So this is the reducing character properties of the hydrides. Then the formation of complex. How the formation of complex, that is the aqueous ammonia forms a stable complex ion with many cations, notably for these transition metals, that is the silver ions, copper ions, Cu2 plus ions. Oxidation, copper having the 2 plus means its oxidation state is +2. Cadmium C2 plus ions, oxidation state is 2. When the cationic form of the silver, that is Eg plus ions, is reacted with the oxidized silver ion, is reacted with the two molecules of the ions, then the formation of the complex, that is the diammonium silver complex having the positive charge, that is the having oxidation state first. Compared with the ammonia, other have the less tendency to form the complexes. That is the ammonia which forms the complexes, but the other molecules which forms the less tendency to form the other molecules which forms, but less tendency to form the complexes, like the trihydrides of the arsenic, trihydrides of bismuth. But the ammonia molecule have the greater tendency to form the complexes molecules. So this is the formation of the complex of hydride sites. Then the sixth properties of the hydrides molecules of P block element is the precipitation of the metals from their aqueous salt solutions. Aqueous salt solution, ammonia precipitates heavy metals as hydroxides, phosphine arsenic, stibine, and bismuthine, and precipitate metals such as silver, copper, etc., as the phosphides, arsenides, and antimonides, bismuthides. Irrespectively, all these elements are forms the or precipitate to form from their aqueous salt solutions. That is the